Hello everybody and welcome back to another Algebra 1 video. Today we'll be covering lesson 3.3, which is the multiplication and division properties of inequalities. In lesson 3.2, which I covered in my previous video, we looked at the addition and subtraction properties. And now we're going to be looking at multiplication and division. Again, it's going to be very similar to the inverse operations that we learned in chapter 1. So let's go ahead and get started by looking at the definition of the property. So in words, if you multiply or divide each side of an inequality by the same positive number, the inequality will remain true. So let's take, for example, the true inequality -6 is less than 8. And let's say we wanted to multiply both sides by +2. If I were to do that, I would get -12 is less than 16. And you can see that the inequality is true. So this demonstrates that if you multiply an inequality by the same positive number, the inequality will still be true. Same applies for division. Let's say I have 6 is greater than -8, which is a true inequality. Go ahead and divide both sides by 2, for example. And if I do that, I get 3 is greater than -4, and that inequality still remains true. So we're going to go ahead and use the multiplication and division properties of inequalities to solve inequalities for a certain variable. Here's the first example. We're going to solve for x, then graph the solution. We have the inequality x over 8 is greater than -5. First, we want to isolate x by identifying what operation is keeping it from being isolated. In this case, it's going to be the division of 8. So for inverse operations, you want to multiply both sides by 8 to cancel it out. 8 will cancel, and you're left with x is greater than -5 times 8, which is -40. And now that you've solved your inequality for x, you can go ahead and graph the solution. There are 3 basic steps to graphing an inequality. First, go ahead and draw your number line, label 0, and then the number where you're going to graph your point. In this case, -40. I went ahead and went by 20s on this inequality, but you can go by whatever increment you'd like. Now you can go ahead and graph your either open or closed circle at your solution. So since this is a greater than sign, we're going to be graphing an open circle at -40. So there it is. And lastly, you can go ahead and draw your line in the same direction as the inequality symbol, as long as your variable is on the left. We can see here that x is already set on the left of the inequality, so we can draw our arrow pointing to the right. And that is how your graph will look like. Here are a few more examples. We're going to solve the inequalities, then graph their solutions. On this slide, I'm just going to go ahead and solve them, and then we'll graph them on the next slide. For the first example, we have n over 7 is greater than or equal to -1. Identify what operation is keeping your variable from being isolated. It's the division of 7. So go ahead and cancel out the division using inverse operations by multiplying 7 on both sides. 7 will cancel out in the n over 7, and then you're left with n is greater than or equal to -7. And there's your final inequality. Let's look at the next example. We have 2k is greater than -10. First, divide both sides by 2. Since the operation that is keeping k from being isolated is the multiplication of 2. So once you divide both sides by 2, 2 and 2 times k will be canceled out, and you're left with k is greater than negative 10 over 2, which would just be negative 5. And there is your final inequality. For the next example, we have negative 6.4 is greater than or equal to W over 5. First, we're going to go ahead and isolate W by multiplying both sides by 5, since the operation that is keeping W from being isolated is this division of 5. So once you multiply both sides by 5, 5 on the right will cancel. And then you're left with negative 6.4 times 5, which would be negative 32. And if you were to leave it as is, you would have negative 32 is greater than or equal to W, but recall that we're going to be graphing this solution. So I would recommend you rearrange this with the variable on the left. So go ahead and switch W and negative 32 and switch the direction of the sign to make sure that the inequality still represents the same values. So in this case, the open side is facing negative 32 and the pointed side of the inequality sign is pointing to W. So just make sure that you're flipping it around. For negative 18 is less than 1.5 Q, the multiplication of 1.5 is keeping Q from being isolated. So undo that by dividing both sides by 1.5. Negative 18 divided by 1.5 would be negative 12. And once again, you have your variable on the right, so negative 12 is less than Q. However, make sure, since you're graphing it, that you're making the variable on the left. So rearrange it by switching Q and negative 12, and then flip your sign to make sure that it's still an accurate inequality. Now let's go ahead and graph the inequalities that we solved for on the previous slide. First, we have n is greater than or equal to negative 7. We have the greater than or equal to sign, so we know that it's going to be a closed point at negative 7. Going to go ahead and plot that, and then label that my point is at negative 7. I went by units of 1 in this case. And now that you've plotted your open or closed point, go ahead and draw your arrow and make sure that your variable is on the left of the inequality. We made sure on the previous slide to set them all up like so. So now you can draw your arrow in the same direction as your inequality symbol, which is to the right. We have k is greater than negative 5. We have a greater than symbol, so we know that this is going to be an open circle. So draw in or plot an open circle at negative 5. I'll go ahead and label negative 5 at our point. And now that you have your point plotted, you can go ahead and draw your arrow. Once again, our variable is located on the left of the inequality, so we can follow the same direction as the symbol, which is again pointing to the right. For W is less than or equal to negative 32, we're going to be using a closed circle at negative 32 for our point. On my number line, I went by units of 8. So negative 32 will be at the 4th tick mark. Go ahead and plot your solid point at negative 32. And since our variable is on the left of the inequality, follow the same direction as the inequality is pointing, which is to the left. For k is greater than negative 12, first go ahead and plot a open point at negative 12, since this is a greater than symbol. I went by units of 6 on my number line, plot my open point there, and since our variable is on the left of the inequality sign, we can follow the same direction as the inequality symbol is pointing, which is to the right. Here are 2 more examples that we're going to solve and then graph. Our first one is x over -3 is greater than 2. Notice here that we're actually dividing x by a negative number. If you recall in the first slide, the multiplication and division properties that we were learning only applied to when you multiplied or divided by a positive number. So in the case of when you're solving for an inequality and you encounter that you have to multiply or divide by a negative number, you always have to flip the symbol when you're solving. Or else if you don't, your inequality will no longer be true. So I'll go ahead and show you this in this example. So first, carry out your normal inverse operations by multiplying both sides by -3. -3 will cancel and you're left with x. Then go ahead and flip your symbol from greater than to less than, and then -6. And there's your final inequality. Now, the reason why you have to flip your symbol is because if you left your symbol as x is greater than -6 and plugged any value that is greater than -6 back into your inequality, you would have, for example, -3 over -3 is greater than 2. Now, -3 is a value that's greater than -6. And if you were to simplify this, you would get that 1 is greater than 2. Now, this is not a true statement. So you have to make sure that you are following the rules, this rule, and able to make a true inequality. Now, if you are following that general rule and you got that x is less than -6, if you were to plug in a value that is less than -6, for example, -12 over -3 is greater than -6, you would get that +4 is greater than -6, and that would be a true inequality. So just make sure that whenever you are multiplying or dividing an inequality by a negative number, that you are flipping the symbol. Same goes for division. We have -7y is less than or equal to -35. Undo this multiplication of -7 by dividing both sides by -7. -7 cancels, and you're left with y, and then flip your symbol to greater than or equal to -35 over -7, which would just be +5. And there is your final inequality. Now we can go ahead and graph the solutions on a number line. First, draw your number line, label 0 and the number that you're going to be plotting your point at. Here is 0 and -6. Plot an open circle at -6 since this is a less than sign. And now you can go ahead and draw your arrow in the same direction as the inequality symbol, since your variable is on the left, which would be pointing to the left. For y is greater than or equal to +5, label 0 and then label 5 on your number line. Then plot a closed circle this time at 5, since this is greater than or equal to. Once you've plot your point, you can draw your arrow in the same direction as your inequality symbol, since your variable is on the left. So this would be pointing to the right. There are 4 more examples that we're going to be doing, just so that we can get used to flipping the sign whenever we are multiplying or dividing an inequality by a negative number. Our first example is p over -4 is less than 7. First, we're going to isolate p by multiplying both sides by -4, since this division of -4 is what is keeping p from being isolated. So once you multiply both sides by -4, -4 will cancel and you're left with p. Then go ahead and flip your sign from less than to greater than, and then simplify 7 times -4, which is -28. And here is your final inequality. Here is our next example. We have 1 is greater than or equal to -1/10 z. What is keeping z from being isolated is this multiplication of -1/10. So we're going to undo that by multiplying by the reciprocal, since we are multiplying by a fraction. So the reciprocal is just the fraction flipped around. -1/10 flipped around would just equal to -10 over 1. And you can see here that if you multiply -10 over 1 by -1/10, they cancel one another out. So now z is isolated. Multiply both sides by -10 over 1. So -10 times 1 would just be -10. And make sure that you flip your inequality symbol from greater than or equal to less than or equal to. So now you have -10 is less than or equal to z. And now you should rearrange your inequality with the variable on the left side, since we are going to graph our solution. You would just switch z and -10 and then flip the sign again. So that would give you z is greater than or equal to -10. Next example is -2r is greater than or equal to -22. Isolate r by dividing both sides by -2 so that you can do this multiplication. -2 will cancel on -2r. And now you can go ahead and flip your sign to less than or equal to, and then bring down your r. Then -22 divided by -2 would give you +11. So your final inequality is r is less than or equal to 11. For our last example, which is -9m is greater than 63, we're going to undo the multiplication by dividing both sides by -9. -9 will cancel, and since we are dividing by a negative number, we're left with m. Then we're going to flip our sign from greater than to less than, and then simplify 63 over -9, which is just -7. Now we can graph all our inequalities. For the first one, we have p is greater than -28. First label 0 and then -28 on your number line. I went by units of 7. Then plot your point at -28. In this case, this will be an open circle since this is greater than. Once you've plot your point, draw your line in the same direction as the inequality symbol since your variable is on the left. So that is pointing towards to the right. For z is greater than or equal to -10, first label 0 and -10 on your number line. I went by units of 2, and then plot a closed circle at -10 since this is greater than or equal to. Once you've plot your point, draw your arrow in the same direction as the inequality symbol since the variable is on the left of the inequality. So our inequality symbol is pointing to the right. For r is less than or equal to 11, first label your number line with 0 and 11. I went by units of 2, so 11 would be between 10 and 12. And you can plot a closed circle at 11 since this is less than or equal to. Once you've plot your point, draw your arrow in the same direction as your symbol since your variable is on the left. For the last one, we have m is less than -7. I did my increments just by ones, and I'm going to plot a open circle at -7 since we have a less than symbol here. Once you've plot your circle, go ahead and draw your arrow in the same direction as the symbol since m is on the left of our inequality. So that would be pointing to the left. Here are two last examples that we're going to be doing. We're going to write the word sentence as an inequality and solve. First, we have a number divided by 8 is less than -2. So whenever they say a number and don't specify what number it is, we can assume that this is an unknown variable. So choose whatever variable you'd like. I'm going to go for x. And then we know that this unknown variable is going to be divided by 8. So we're going to go ahead and indicate that x is divided by 8. And now go ahead and put your inequality symbol. We have the key phrase less than, so we know that we're just going to be using the less than symbol for this inequality. And then lastly, we have less than -2. So set your inequality to -2. Now that you have your inequality, you can go ahead and solve it. So x over -8 is less than -2. Undo the division by multiplying both sides by 8. 8 will cancel. And now you have x is less than, and then simplify -2 times 8, which would be -16. For number 2, we have the product of -5 and a number is greater than 20. So once again, we have a number, so that refers to an unknown variable. We also know that our inequality symbol is going to be represented by this greater than key phrase, which is just the greater than symbol, and that our inequality is going to be set to 20. For the first part, we know that it's going to be the product of -5 and our unknown variable. Once again, I'll use the variable x. So product of -5 and our unknown variable would just be -5x. And then we have our inequality symbol, which is greater than. And then lastly, what our inequality is set to, which is +20. Now that you have your inequality, go ahead and solve it for x by first dividing both sides by -5. -5 will cancel. Now you're left with x is less than. Now notice that you're actually dividing both sides by a negative number and that you're going to have to flip the symbol. So make sure you're paying attention to that whenever you're solving an inequality. So you have x is less than, and then simplify 20 over -5, which would be -4. And there's your final inequality. That is the end of today's lesson. As always, all information regarding tutoring, lesson requests, and additional practice will be linked down below in the description box. Thank you so much for watching, and I hope to see you in the next video.